Okay, BC kids, so this is Unit 4 continued, Lesson 3. We're going to be finding volume by the disk method. Okay, so here's what you have to imagine. You have to imagine that you have some two-dimensional shape. Just picture an index card. Remember learning in geometry when you had to rotate that card? Remember it created a cylinder? So basically what you're going to think of here is creating an infinite number of cylinders with infinitesimal thickness. Okay, so let's just jump right in. So this is the disk method. So you're going to be doing a revolution. Okay, so number one, let me give you a function. Let's say we have y equals 9 minus x squared. Number one, let's draw this function. So this is just an upside down parabola shifted up to 9. And it passes through -3 and 3. Okay. So it all depends on what you're being asked to revolve around, okay? And what you're going to do is you're going to draw a picture. So for the first example, let's say we want to revolve around the x-axis. Okay? So for here, I'm going to draw a radius. So this is going to turn into a cylinder when it revolves around the x-axis. Okay, this here, it may look like a rectangle to you, but it's not because it's spinning around the x-axis, so it's going to spin out a cylinder. Okay, so you're going to have this little cylindrical piece. So what happens here is you have to think of your how you get, with a little cylinder, how you get the volume, right? So if I have this little cylinder here, okay, how do I get the volume if I have the radius, right? So I have my radius, so my volume is pi r squared h, right? So here I have to think, okay, well, what's r? Okay, well, my radius in this case is 9 minus x squared. So my volume is pi times the integral from -3 to 3. And then I have my radius squared. So think about it. This is going to be 9 minus x squared squared dx. The height of each of my little cylinders is dx, okay? So that's what's going on with that question. And then, of course, you'd have to do the problem, okay? Next, let's say we're revolving it around the line. We'll say y equals -2. Okay, number one, I have to get the intersection, right? Where does 9 minus x squared, where does that intersect -2? All right, so if I subtract 9, I end up with -11. Then I divide by -1, so I get 11. So I'm going to have plus or minus the square root of 11. So those would be my x values. All right, so you need to picture this. So here, in my first problem, that was my x-axis, right? So in my second problem, I have the same picture. This is my x-axis, but now it's going down further. And I'm revolving it around the line y equals -2, which is a horizontal line. So now you have to picture, okay, what's my radius? Okay, this is my radius. So my radius, in this case, is 9 minus x squared minus -2. which is just 9 plus 2, which becomes 11. So my radius, keep in mind, I'm going to square it, right? And my integral is going to be going from negative square root of 11 to the square root of 11. And the pi would go outside. So that's how you would calculate your volume. Okay, you would have a calculator to do something like that. Now let's say I did the same thing, but instead I revolved it going around the y-axis. Okay, so let's see what would happen here. So, same thing. Okay, I'm going to restrict x equal to 0 and y equal to 0 in this case, though. So instead, here, I'm just going to have this part of my parabola. Okay? So I'm going to revolve this. So my region, okay, my region that I'm revolving is created by y equals 9 minus x squared and x equals 0, which is the y-axis, right? And y equals 0, which is the x-axis. So this is my region. Okay, so I'm going to revolve this around the y-axis. Revolve, okay, about the y-axis. So in this case, my diameter, I have to switch my function. I have 9 minus x squared, right, equals y. So I'm going to have to solve for x in terms of y. So I get x squared is 9 minus y. And then I have to square root both sides. So I get 9 minus y, square root, equals x. Okay, so I'm just solving for x. So this part of the function is only the positive part of the square root anyway. So we have the square root of 9 minus y. So that is my radius. So the r, the radius, is the square root of 9 minus y. So the volume, right, is pi r squared h. So I'd have pi. My r squared is going to end up just being 9 minus y. So this cleans up to a nice problem. My dh will now be dy. I mean, my h will be dy, sorry. And my bounds of integration, I'm going from 0 to 9. Okay, because my bounds are in terms of y. So that's how you'd find the volume here. All right, so in class we will get to, trickier questions. I'm going to leave it here. This is the basic idea that you have to come into class with. Thank you, guys.